Welcome to a new topic, longitudes and latitudes. Just as we use coordinate system to locate points on a Cartesian plane, it's the same way we use latitude and longitude to locate points on the Earth's surface. When we talk about latitude, as some of you have learned in geography, latitude are imaginary lines showing how far a place is north or south of the equator. And when we talk about a longitude, they are imaginary lines that shows how far east or west a place is from the Greenwich Meridian. Greenwich Meridian can also be called the prime meridian. Now, you can see these that runs across from the east to the west. These are the latitudes. These are the latitudes. These are the latitudes. And these that runs vertically, they are the longitudes. At the middle here, we have what we call a Greenwich Meridian, which is at 0 degrees. And at the center cross here, we have the equator, which is running across, is a latitude, which is running across, and it's at 0 degrees. So those are the latitudes and the longitudes. Like you can see, this on a globe, and this is on a flat world map, and this is on a world globe. Now, let's talk about great and small circles. When we talk about great circles, they are also called longitudes. These are lines that run up and down on a map or a globe, like we have seen from above. That these are the great circles. They run from the north to the south. They run up and down on a map. These are the great circles. The longitudes are great circles. The longitudes are great circles. And they are always listed second when signing a measurement. For instance, like coordinates, we say XY. In this case, for locating points on the globe, we use latitude followed by a longitude. A latitude followed by a longitude. So on a Cartesian plane, we use XY. And on the globe, we use latitude followed by a longitude. Like in this case, the longitude is 60 degrees and the latitude is a latitude followed by a longitude. And then when we talk about small circles, they are also called latitudes. They are lines that run left to right on a map or a globe. They are lines that run left or the right on a map or a globe. These lines that run across left or to the right of a globe, they are the ones we call the small circles or latitudes. And they always listed first when assigning a measurement. They are now the X. On a Cartesian plane, we say XY. Now the latitudes becomes the X here. So when naming on a globe, we say latitude followed by longitude. In this case, the latitude is 60 degrees. Now, when we talk about a prime meridian, it's also called a Greenwich Meridian. Greenwich Meridian or prime meridian are found at 0 degrees longitude. So the longitude at the center, of the globe, is what we call the Greenwich Meridian or the prime meridian. And we have 180 degrees east and west from the Greenwich Meridian or the prime meridian to the international date line. So we have from the Greenwich Meridian to the east, or longitudes here, to the west, or to the east. They are 180 to the east or 180 to the west. Now, when we talk about the equator is found at 0 degrees latitude. At 0 degrees latitude. So the latitude at this point is 0 degrees. 0 degrees. So we had a latitude, a longitude here, which is 0 degrees, we called it a prime meridian, and we have a latitude at 0 degrees here, we call it an equator. They are 90 degrees to each of the poles, that is either the North Pole or the South Poles. From the equator to the North Pole is 90 degrees, and from the equator to the South Pole, it is also 90 degrees. From the equator to the South Pole is 90 degrees, and from the equator to the North Pole is also 90 degrees. And the other side, we have said this is 180 degrees. Now, you realize that the equator is the only great circle because it's the longest line, it's the longest latitude. Being the longest latitude, it is the only great circle. It is the only latitude that is a great circle. The only latitude that is a great circle is the equator. Let's now talk on how we can locate position on the Earth's surface. Now, we have said from above that the Earth is described by latitude, that is north or south, and the longitude, east or west, in that order. That means you start with a latitude followed by a longitude on the globe. For example, we can say that Nairobi has a coordinate of 1 degrees south and 37 degrees east. This means that its position is 1 degree to the south of the equator, and that 7 degrees east of the prime meridian, and that 7 degrees east of the prime meridian. Now, if you are given points to locate, the first thing you do, like if you are asked to give to locate these positions, east, that is E, we have point A, point B, point C, point D. If you are asked to locate them, first of all, you realize that this is our equator. So C lies on the equator. C lies on the equator, and the equator is 0 degrees. And then you realize that we also have our Greenwich Meridian, which is here. This is our Greenwich Meridian. It's also at 0 degrees. Now, endpoint that can lie here at this line, it is at 0 degrees longitude, or the Green Meridian, that's longitude, at 0 degrees longitude. And the endpoint that lies at the equator, it is at 0 degrees latitude. And therefore, if you want to name a point, let's start with A. Point A, you can see it lies on this latitude, and also lies on this longitude. Now you have to look keenly and see that latitude is what, and the longitude at that point is what. The longitude here, this longitude, it is the one here, is 60 degrees east. And the latitude at this point is the one here, which is 80 degrees north. So we start with latitude followed by a longitude. And therefore point A, it is 80 degrees north and 60 degrees east. 80 degrees north, 60 degrees east. You have located point A. And if you are asked to locate point B here, it will be, you start with the latitude. This latitude is 30 degrees north. So it will be 30 degrees north. You now read this longitude, it is 80 degrees east. So it will be 30, point B will be 30 degrees north, 80 degrees east, 30 degrees north, 80 degrees east. What about point C? Point C lies on the equator. Lying on the equator, now we start with 0 degrees. For equator, you don't say north or south because it's just at 0 degrees at the center. So it is neither south nor north. So the equator is 0 degrees. Followed by the longitude here, you have to look where it is named. The longitude, this longitude is here. It is named as 60 degrees east. So it will be, C will be 0 degrees and 60 degrees east. 0 degrees and 60 degrees east. That is our C. Our point D here. This our point D, you start with this latitude. And the latitude of D here, it is 60 degrees south. So it is 60 degrees south, followed by the longitude is named here, which is 40 degrees east. So it is 60 degrees south, 40 degrees east. 60 degrees south, 40 degrees east. And then you go to point E. Point E is here. The latitude here, we have seen the latitude is 30 degrees north. So it will start as 30 degrees north, and the longitude is named as 20 degrees west. So it will be 30 degrees north, 20 degrees west. 30 degrees north, 20 degrees west. That's point E. So that is how you locate points on the globe. Now, let's talk about the difference in longitude. How do we find difference in longitude? Now, if places are on the same side of the prime meridian, the prime meridian is here, or the Greenwich Meridian. If they are on the same side of the prime meridian, like all points, if we are talking about here and another point here, they are on the same side of the Greenwich Meridian, then we subtract. And if they are on opposite side of the Greenwich Meridian, like for instance, we talk about a point here, E, and a point B. They are on different side of the Greenwich Meridian. So the difference in the longitude will be the addition. If they are in different part of the Greenwich Meridian, is the addition. And for latitude difference is the same way you do. If they are on the same side of the equator, like all the equator is here, all the points below the equator, because they are on the same side, or above the equator, because they are on the same side, we subtract. But if they are on different sides, like one is on the south, another one is on the north, we add. So that is how we find the latitude difference and the longitude difference. Remember, that one is key, because it will help us in calculating the distances. So you should be able to know on how to get the latitude and longitude differences for you to be able to calculate the distances as we are going to learn. An example, difference in longitude between A and B, between this A and B. Longitude difference. So specifically, we are talking about the longitude difference. This is our longitude and this is our longitude. This is towards the east and this is also towards the east. Because they are on the same side, we subtract. So the longitude difference will be 80 minus 60, which is 20 degrees. 80 minus 60, which is 20 degrees. And between E and D, longitude difference between E and D. Now we have E. We have our E is here and our D is here. The longitude difference between the two, our longitude is towards the east and our longitude is towards the west here. So this longitude 40 degrees east, 20 degrees west, because they are on different side of the Greenwich Meridian, we add. So we shall add 40 plus 20, we get 60. So it will be 40 plus 20, which is 60 degrees. That is the longitude difference between the 2 points. Now, another one is that the latitude difference between A and C. The latitude difference between A and C. Between A and C, we have A and C. Remember here, A is 80 degrees north and C is 0 degrees. That's the latitude. You know, even if you add 80 plus 0 is 80, 80 minus 0 is 80, because it is at the center, so whether you minus, whether you subtract, is the same thing you get 80 degrees. So the latitude difference will be 80 degrees. Now between E and A, we have E and A. The latitude difference, remember this is 80 degrees north and this is 30 degrees north. Because they are on the same side of the equator, we subtract. So it will be 80 degrees north minus 30 degrees north, which gives you 50 degrees. Which gives you 80 minus 30 gives you 50 degrees. Now we have between the latitude difference between D and A. Between D and A. the latitude difference between D and A. Between D and A, the latitude difference between D, this is our D, and our A. This is 80 degrees north, and our D is 60 degrees south. Now the latitude difference, because they are on different part of the equator, on the opposite side of the equator, so we shall add 80 degrees plus 60 degrees, which gives you 140 degrees. Remember longitude difference and the latitude difference, you might find some places talking about the angular distance. So if you are asked to find the angular distance, it's the same as the longitude difference. The angular distance is the same as the longitude difference. So you get in terms of degrees. Now, let's talk about distance on the surface of the earth. How do we calculate the distance on the surface of the earth? So like we have said, we have two distances. That is distance along the great circle, that is on the fat core, and distance along the small circles, that are the latitudes. So we want to start with the great circle distance. That is for you to calculate along the great circle distance on longitudes or on the equator. So equator is the only great circle that we said, is the only latitude that is a great circle. So distance on longitudes and on the equator, these are great circle distances. I hope you remember in Form 2 and Form 1, you learned about length of an arc. To find length of an arc, it is L equals to theta over 360 degrees times 2 pi r, where in this case r is the radius and the theta is the angle subtended by this at the center of the arc. Now the same formula will be used to find the length along a longitude. The same formula will be used to find length along a longitude or great circles. But now in this case, theta is the degree of the central angle, that is the latitude difference. Remember, if you are talking about longitude, the theta becomes the latitude difference, because the longitude, you realize, will always be the same. And the radius of the earth is usually given as 6370 kilometers, that is approximately, unless given otherwise. If you are not given another value as the r in this case will be r capital. In our formula, we shall substitute r capital to use it on calculated distance along the longitudes or along the great circles. So I've said that the radius r capital is usually given as 6370 kilometers approximately, unless given otherwise. Another formula that can be used to calculate, that is in nautical miles, we use 60 times theta, and the theta we have said is the angle, is the latitude difference in this case. The angle subtended at the center of the globe, that is the latitude difference. So it is 60 times theta in nautical miles, and that comes from, we understand that 1 degree is subtended by 60 nautical miles. 1 degree is subtended by 60 nautical miles. So if 1 degree is subtended by 1 nautical mile, then by 60 nautical miles, what about those degrees that you found? You will find those degrees times 60, and that is where we get the formula 60 times theta. So it is 60 times theta to get in nautical miles. And you realize that 1 nautical mile equals to 1.853 kilometers. That's approximately. It is 1.853 kilometers. And then you need to understand this. If you are given in minutes and apostrophe above some degrees, some numbers, like if it was year, 30 apostrophe above, so that means minutes. And 1 degree is equals to 60 minutes. You need to know that in terms of angles, 1 degree is equals to 60 minutes. And you should not get confused between here and when we talk about minutes, when we shall talk about time later in this topic. In this case, 1 degree is equals to 60 minutes. So you need to note it. Example of a question. Find the distance between point P, 40 degrees north, 50 degrees east, and point Q, 20 degrees 30 minutes south, 50 degrees east, and express it in nautical miles and in kilometers. You take radius of the earth to be 6370 kilometers. Now, the first thing you need, remember, we are finding the distance between this point. Remember this 40 degrees and this one is 20 degrees, but this is 50 east and this is 50 east. What you do, it's good to sketch. Sketching is the most important part in this topic. You need to always sketch. So if I sketch, I have my sketch here of a globe. After having that, you sketch an equator. That is an equator at the center. You also not to sketch. You also need to sketch the equator. This is the Greenwich Meridian or the prime meridian, and this is your equator. After sketching that, now you locate the points as given. This you need to change it into degrees. We know that 1 degree is equals to 60 minutes. What about 30 minutes? It will be 30 divided by 60, which is half, which is 0.5. So this angle is the same as 20.5 degrees south. Now, you need to locate that 20 degrees. If we start with point P, we need to locate point P, 40 degrees north and 50 degrees east. 40 degrees north, 50 degrees east. Now, we need to locate that point where it is. We need to locate that point where it is. Now, you come here and locate 40 degrees north. 40 degrees north. It must be above the equator, so we can have it here. You need to think mathematically where you can locate that, and then we give it as 40 degrees north. 40 degrees north. And you also have another point, 50 degrees east. The east is towards this side, so 50 degrees east. We can have a point of 50 degrees towards the east. 50 degrees towards the east, we can have it here. We can name it as 50 degrees towards the east. 50 degrees east. After naming this point 50 degrees east, now we can locate that point and name it to point what? It is point P. So we have to call it point. That is our point. Just give it a letter, point P. So having point P there, we need also to locate another point that is 20.5 degrees south. 20.5 degrees, that's a latitude. Remember we said we start with the latitude. 20.5 degrees south. So if we come 20.5 degrees south, 20.5 degrees south, we can have it here. You start from the equator downwards, you can have it here, and we can name it as 20.5 degrees. You can name it as 20.5 degrees, 20.5 degrees degrees of the south. 20.5 degrees south. We can also have 50 degrees north. We can also have 50 degrees north. We can also have 50 degrees north. If this is 40, 50 degrees east. So the 50 degrees east was this same line. Remember this 50 degrees to the south, and it's on latitude 50 degrees, on longitude 50 degrees east. So it is still, the point is here. This is the point. So if you locate your point here, give it point Q, give it point Q, so you can name, that is where you have point Q. That is point Q. Now we need to find out the distance between P and Q. P and Q. No. P, we named it wrongly because it was supposed to be 40 degrees north. 40 degrees north and 50 degrees east. It's supposed to be here. Our point is supposed to be here, so that we find between here, between this point here. This is where we are supposed to have our P here. So our P and Q here. We need to, so you just sketch. After sketching, then you are able to give the values, this 50 degrees east and 50 degrees. So we've calculated the latitude difference, so that we are able to find this distance here. So the latitude difference, remember, it is south, another one is north. So if there are different part of the equator, opposite side of the equator, we say that we add. So we shall add 40 plus this, which gives you 60.5. Now in nautical miles, it will be 60 times 60.5. It will be, in terms of nautical miles, it will be 60 times 60.5. That gives you 3,630 nautical miles. That is the distance. And in kilometers, we use the formula that is theta all over 360 2 pi r. Theta all over 360 2 pi r. So this will be equal to the 60.5 that we have got all over 360 times 2 times 20 over 7 times 6370. If you use your calculator and do it correctly, you will find 6729 kilometers. So that is the distance in kilometers and the distance in nautical miles. So the latitude difference times 60 gives you the distance in nautical miles. And the latitude difference all over 360 times 2 times pi times r. R is usually 6370 unless given otherwise. So you calculate, you get your distance in kilometers. So that is how simple you find the distances along longitudes. That is how you find distances along longitudes. Number 2, find the distance between point A, 0 degrees and 30 degrees east, and 0 degrees and 50 degrees east, and express it in nautical miles and in kilometers. Remember, these 2 points lie on the equator. 0 degrees, 0 degrees. That's the latitude. 0 is the equator. If they are on the equator, they lie on the equator. So I said the first thing we do is to make a sketch. That's the first thing we do. We make a sketch. If I make a sketch here, it does not look good. It does not look good. If I made a sketch, that is better. If I make a sketch there, so I need to draw the equator and the Greenwich Meridian. If I use this red for the Greenwich Meridian at the middle, and I use blue for the equator. I use blue for the equator, and then the equator is at 0 degrees, of course we know, and the Greenwich Meridian at 0 degrees. So you are asked about a point A, which is at equator 0 degrees and 30 degrees east. So we need to locate 30 degrees east. The east is this side, so if I draw a sketch at 30 degrees, I call this point, I call it 30 degrees east. I call it 30 degrees east, and I have another 0 degrees and 50 degrees east. So 50 degrees mathematically obvious should be towards this side. So if I use like purple, and then I create a 50 degrees towards that point east. So 50 degrees east, we shall have another point here. This is the point we are talking about. That's point B, and this is point A. So you have this point and this point, A, B. You need to know them. So this is 50 degrees, of course, 50 degrees east. This is 50. That is our 50 degrees to the east, 50 degrees to the east, 50 degrees to the east. So we have our 50 degrees to the east, this is the point, and we also have 30 degrees to the east, this is the point A and point B. Now we need to find what we call in this case we need to find the longitude difference. Yes, we get the longitude difference, but we use the formula for the great circle, not for the small circle. We are using the longitude difference, but we use the formula for the great circle for us to find. So it will be, you realize that the 2 points, they lie on the equator, and the equator we said is a great circle. And therefore we are calculating the distance along a great circle. And the angle between here and the B now becomes the longitude difference, which is 50 minus 30, which gives you 20 degrees. And therefore the distance in nautical miles will be 60 times 20, which gives you 1,200 nautical miles. And the distance in kilometers will be now the 20 all over 360 times 63 or 70 times 2 times 20 over 7. That is by saying theta all over 360 pi 2 pi r. And remember, it is theta we said is for great circles is latitude difference, but because this is a latitude that is at the center, and therefore which is the equator, which is the only great circle, we use this formula for calculating the distance along great circles. So you will find 24 kilometers in terms of kilometers, and in terms of nautical mile, this is what you get. Now, let's talk about distance along a small circle. That is the circle of latitudes. Now, you realize that in this case you need to know 2 formulas. That is to get the distance in nautical miles. The other one we said it is 60 times theta, but this one I want to use alpha. I'll give you the reason. So the formula in nautical miles, it is 60 times alpha times the cos of theta. And in kilometers, it is alpha over 360 times 2 pi r cos theta. Now we need to know what is cos theta and what is alpha. What is alpha and what is theta? The alpha now is that angle subtended at the center, because we are talking about distance along the latitudes. So we use the longitude difference. So the alpha is the longitude difference. The angle subtended at the center will be the longitude difference. Whereas the theta now becomes the latitude angle. That is the angle which is usually common. Like you've seen from above, when we were talking about the equator, it was 0 degrees, 0 degrees. So the common angle there, 0 was common on both sides. So the common angle is what we usually use as theta in this case. And the alpha is that longitude difference. An example, find the distance in kilometers and nautical miles between 2 points. Point P, 30 degrees north, 45 degrees east. And point Q, 30 degrees north and 60 degrees west. We are asked to find the distance. So the first thing I explained from above is to sketch. So you need to make your sketch. Now if I make my sketch here, I make a circle. That's a sphere. Then I need to have the Greenwich Meridian, and I need to have an equator. So if this is the Greenwich Meridian and this is our equator here, now what you do, you locate point P, and the point P will be 30 degrees north. Now if I move to the north, I locate some 30 degrees. Mathematically, I can have my 30 here. If I have my 30 degrees north, I can call this 30 degrees north. I can call that one 30 degrees north. If I have my 30 degrees north there, and then I also need 45 degrees east. 45 degrees to the east. East is towards this side. So if I talk about a 45 degrees to the east, if I have a 45, I call this 45. If I call this 45 degrees to the east, 45 degrees east, so this becomes my point P. This is my point P. My point P is there. I need to locate my point Q, which is 30 degrees north. Remember, this is my 30 degrees to the north, and 60 degrees to the west, and 60 degrees to the west, and 60 degrees to the west, and 60 degrees to the west. So if I get my 60 degrees to the west, mathematically I can have it there. I call that my 60 degrees to the west. And therefore, remember, I'm talking about that degrees north and 60 degrees west. So this becomes my point. This is my point Q. I call this my point Q. A point Q. My point Q is there. So you have my point Q and my point P. PQ. So these are the 2 points I'm dealing with. This one, this point, and this point here. My point Q and P. So I need to calculate distance along this. This is a latitude. This is a latitude. So you realize for a latitude, it's at latitude 30 degrees. But what is different now is the longitude. This is 45 degrees and 60 degrees. This is to the east and this is to the west. I said now to get the longitude difference, because they are on different, in the opposite side of the Greenwich Meridian, we add. And therefore, my longitude difference will be 45 plus 60, which is 105 degrees. That is the angle that will be subtended by the arc PQ. Arc PQ, this is the arc, subtends to the center. Remember, if we add the center here, it subtends an angle to the center. The angle subtended to the center here by this arc. This is an arc. The angle subtended by this arc at the center here is 105 degrees. That's the angle that will be subtended here. 105 degrees. Now, the 105 degrees, that's our longitude difference, is what we will use to calculate the distance along this latitude. Now, in nautical miles, it will be 60. In nautical miles, it will be 60, the 60 degrees, times, it will be the 60 degrees times 105 times cos of 30 degrees, times the cos of 30 degrees. This is the 30 degrees, which is common. So, and in kilometers, we shall use the formula theta over 360 times 2 pi r cos theta, which our theta is, our alpha now is 105. So it will be 105 times 2 times 10 over 7 times 6370 cos of 30, and which gives you 10,113 kilometers. And the length PQ in nautical miles is just 60 times alpha times cos of theta, which I've said it is 60 times 105 times the cos of 30 nautical miles, which is 60 times 105 times this cos 30 is 0.8660, which gives you 5,456 nautical miles. So that is how we calculate the distance both in nautical miles and in kilometers. Now, let's talk about shortest distance between the 2 points on the Earth's surface. Between 2 points on the Earth's surface. Now, you realize that shortest distance between 2 points on the Earth's surface is along great circles. Along great circles, that's where we have the shortest distance. Along great circles, that's where we have the shortest distance. But if you are asked to calculate shortest distance along the parallel of latitude, remember, we have a latitude, and then you are being asked, this is a latitude. We have already understood that shortest distance is along longitudes, but you are given a latitude, and you are asked to find a distance between a latitude. It is just between PQ in a latitude, and then you are asked to find the shortest distance along the parallel of latitude. In that case, remember for latitudes we said we use our alpha as the longitude difference. So in this case, the longitude difference must be equal to 180. If it is not equal to 180, you cannot be able to find the shortest distance along the parallel of latitude. But if it equals to 180, then you are able to do that. An example: P and Q are 2 points on latitude 50 degrees north. They are both on latitude 50 degrees north. They are on a longitude 48 degrees west and 132 degrees east respectively. Find the distance between P and Q, A along parallel of latitude, B along a great circle. Now, along parallel of latitude, along a great circle, that is now which would be the shortest distance. Remember now our longitude difference is 48 west and 132 east. So longitude difference, if you because they are west and east, you add. If you add the two, gives you 180 degrees, like I said. So now that it's 180 degrees, you are able to do. So what you do along parallel of latitude, we use now, that's the difference of longitude I've said is 180 degrees, and the length of the circle parallel of latitude 50 degrees north is theta all over 360 2 pi r cos of theta. Cos of theta. I have said, remember it is a latitude, and the latitude, this is how we have said we calculate. It's alpha over 360 times 2 pi r cos of theta. This theta becomes 50 degrees because that is the latitude, and alpha becomes the longitude difference. So it is 180 over 360 times 2 times all this cos of 50, which gives you 12,869 kilometers. Now, when we talk about if we sketch what we are told here, let's have a sketch here. And then we have a Greenwich Meridian here. And then we have an equator. If I have an equator like here, and then I have 50 degrees north, because I'm told 50 degrees north. 50 degrees north. If I have some 50 degrees to the north, let me have it here. Let me call it 50 degrees north. 50 degrees to the north. I have 50 degrees to the north. And then I have 40 degrees west. Remember, both of them are in the same latitude. Now we are told the longitudes are 48 degrees west. So we have a 48 degrees west. A 48 degrees west. If I have a 48 degrees to the west, so the west, this is the west, this is the west. I have a 48 degrees towards the west. Let me call it 48. 48 degrees west. I have 48 degrees west, and I have 132 degrees to the east. 132 degrees to the east. 132 degrees to the east. So if I have 132 degrees to the east, call this 132 degrees to the east. I have that as 132 degrees to the east, and both of them are, so this is the points P and Q. This is point P, which is this is my point P here. Point P is here. That's point P, and this is my point Q. The point Q is here. My point Q will be here. My point, I have my point Q there. So if I have my point Q here and my point P here, so this is the distance we are talking about. Remember, the center is here. This is to the center. So if this is if I have the center, remember the equator is here, that is the center is this point. If this is the equator, I have an angle that it would be subtended at the center here. I have that, and I have this one. Then I have this arc, the arc here, which is P, my P, and my Q here. My Q is here. So I have my Q there. Now, what you'll realize is that now we have a 50 degrees, the latitude is 50 degrees, so this is latitude is 50. If we have 50 degrees in both, and I have 50 degrees in both. Now, for you to calculate the angle that you use for you to calculate the distance along the longitude, remember I'm asking along the longitude, and the longitude is towards the north. Is towards the north, 50 degrees north, and therefore there is an angle that will be subtended here at the center for you to get distance along the longitude. So we shall have the angle here. Obviously, we know angle on a straight line add up to 180, and therefore 180 minus this 50 and 50, this is 100. So 180 minus 2 times 50, it becomes 180 minus 100, which is 80 degrees. So you will find here as your 80 degrees. You find as your 80 degrees. So that is the angle that will be subtended. And therefore, like I've said, for you to calculate great circle passes via the North Pole, you realize that the great circle will pass via the North Pole, towards the North Pole. That's 50 degrees to the North Pole. That's where the great circle will pass. Like I have done what I've explained here. So, towards the North Pole, and therefore the angle subtended at the center by the arc will be 180 minus 2 times 50, which is 80 degrees, like I've explained. And therefore the length becomes now 80 over 360 times 2 times 20 over 7 times 6370, which is equal to 8898, that is 8,898 kilometers. So that is how we calculate, the distance along a great circle, in the parallel of latitude. Remember, we are given the parallel of latitude from here to here, but we are asked along a great circle, which is a great circle, along a great circle. So we must make this the latitude. Remember, from this point we have the latitude 50 degrees, 50 degrees, and 50 degrees, so that we get, and I've said that the angle longitude difference must always be 180 degrees. If it is not 180 degrees, you are unable to do that question. Yeah, that is what you are required to do. Now let's talk about another example here. The position of two towns A and B on the Earth's surface are 36 degrees north, 49 degrees east, and 36 degrees north, and 1 degrees west, respectively. Earth's radius is given as this, and pi as 22/7. Find the longitudinal difference between the 2 points. Longitude difference is 131. West and east, we add the 2. Because they are west and east, we add the 2, which gives you 180 degrees. Part B, we calculate the distance between the towns. So like I said, between the towns, the distance between the towns along a circle of latitudes. For latitude, it will be correct because it's along the latitude. And along the great circle in kilometers and nautical miles. Great circle, in this case, will be also towards the north. And then we shall have 36 and 36 degrees, like I did from the other side. So the angle that shall be extended, like I explained from above, the angle that shall be extended at the center will be 180, because this and the difference, remember, is 180. So it will be 180 minus 36 times 2, which is 72. 180 minus 72, that is 180 minus 72, like you can see here, which gives you 180 degrees. This is the angle that will be subtended at the center of that arc for part B. For part A is direct because the difference is 180. So we use 180 over 360 times 2 times 22 over 7 times 6370 times the cos of 36, because the latitude is 36. So you get your answer 16,196.52 kilometers. And the angle now subtended at the center, that is for you to find along the great circle. That's the great circle, remember, will be towards the north. And therefore the angle like I've explained, is 108. So it will be 108 over 360 times 2 times 22 over 7 times 6370. Remember, this a great circle does not have cos. Cos you use only for latitude and for small circles. And you find 12,012 kilometers. 12,012 kilometers is smaller than 16,106. So that is why we say this is the smallest distance. It's the shortest distance. And the shortest distance is the shortest distance between this point A and B. It is the shortest distance along a great circle. So the shortest distance is along a great circle and not along the latitude. Remember, it's point P, A and B, but you realize along a great circle is smaller than along the latitude. So along a great circle is the shortest distance, like I've explained from above. Now, part C was another town C is 840 kilometers due east to town B. Due east to town B. Okay, the position of C. Remember, C is due east of town B. And town B is 36 and 131 degrees west. So if we have 131 degrees west, okay, I can have a small sketch for the two, just for those points. For those points, let me have a small sketch here for you to understand what I mean. Let me talk about the equator is there. Let me talk about the equator is here. Let me talk about that's the Greenwich Meridian and the equator here. And then I can talk about now I can locate the points 36 degrees north. So for 36 degrees north, if I locate that point there as your 36 degrees north, let me call it 36 degrees towards the north. 6 degrees north. If you also have 49 degrees east as your point A, 49 degrees east as your point A, 49 degrees east, 49 degrees east as your point A, if I give this as your 49 degrees, east, both are in this latitude, so that is the point. This is our point A, and our point B is 131 degrees west. 131 degrees west. 131 degrees west. 1 degrees. If I talk about 131 degrees to the west, call this 131 degrees to the west. Drawing might not be so good, but the most important thing is for you to understand what I mean. It's 131 degrees to the west. The most important thing is you understand what I mean. So this is the point I'm talking about here. It's point B. It's our point B. Our point B. And our point A is here. The point A is there, and the point B is here. Now the 2 points are here. They are both in latitude 36 degrees north. This is on longitude 49 degrees east, 131 west. And then you are told that another town C is 840 kilometers due east of town B. Due east of town B. So the town C is due east of this. So it must be in of this point. Inside of that. So your C will be around here. This will be your C. This is where your town C will be. Town C is there. So if we have your town C here, now we have this and this. So the sketch is very important. It's good to sketch for you to be able to do the calculations. Now, locate the position of C, but we don't know the latitude for C, because we know it will be on latitude 36 degrees north, but the longitude we don't know. So we need the longitude difference. For you to calculate the distance from here to here, we use, remember this is along the latitude, we use longitude difference all over 360 times 2 pi r times the cos of that 60 degrees, because it's on latitude, times the cos of that 60 degrees. So we will say, we will let this distance to be x. If we let this distance, the longitude difference to be x, then this one will be x all over 360 times 2 times 24 times 63, 70 times the cos of 36 will give you the distance between the two, which is 840 kilometers. So we substitute and find the value of x. If we calculate, and the value of x will be 9.3353. If this is the value of x as 9.33, we know 131 west, and this is also the same side of the longitude. They are pulled towards the west. If they are pulled towards the west, now the longitude difference you are supposed to subtract, because they are on the same direction. This one is bigger than this, so it will be 131 minus y equals to 9.33. And if that is the case, that means you can easily get your 121 here as this 131 we minus this one gives you, okay, that means for you to get this angle, it should be 131 minus the 9 point minus the difference between here to get this angle, because the difference is 9.3, because you are reducing. So it will be 131 minus 9.33. You reduce and you part the angle which is here. So it will be 131 minus 9.3353 west to get 121.7 degrees west. Remember, both are towards the west. So the location for C, it is 36 degrees north and 121.7 degrees west. So location of C is 36 degrees north and 121.7 degrees west. So that is how we locate points. If you are not given the point, you calculate and find that point. You just follow the formulas and you locate the point so easily. So that is how simple the question was. Now, let's talk about longitude and time. Longitude and time. Now, we realize that the Earth rotates through 360 degrees about its axis every 24 hours in west-east direction. The Earth rotates from west to east. And therefore, for every 1 degree change in the longitude, there is a corresponding change in time of 4 minutes. For every 1 degree change in the longitude, there is a corresponding change in time of 4 minutes. There is a corresponding change in time of 4 minutes. Yes. So which is that is the 15 degrees that will be along that latitude. So all places in the same meridian, remember what we mean by the meridian, have same local time. So either to the west, if all times from Greenwich Meridian, all points, all locations to the west, they have the same local time. And towards the east, they also have the same local time. That is, local time at Greenwich Meridian is called the green mean time. Green mean time, GMT. That's the reference point. And all meridians to the west of Greenwich Meridian have sunrise after the meridian, and their local time are behind GMT. So the local time to the west are behind. And all meridian to the east of the Greenwich Meridian have sunrise before the meridian, and their local time are ahead of the GMT. So to the east they are ahead, and to the west they are behind the GMT. The Greenwich Meridian time, mean time, the Greenwich mean time. So in simple terms, to the east we add, and to the west we subtract. To the east we add, and to the west we subtract. Example, find the local time in Nairobi 1 degree south, that's 7 degrees east. When the local time of Mandera, that's Mandera is 4 degrees north and for 2 degrees east is 3 p.m. Mandera is 3 p.m. Now what to do, it's good to sketch, as I have said before. Always in these questions, sketching is very essential, because you'll know that point, is it to the east of the other or is it to the west of the other. So it's just very good to sketch all the time. So if I sketch, I have a point at the middle here, and I have another point. Let me use the same color, it's no big deal. I only want you to understand. Now 1 degree south, if I locate this is 1 degree south, if I say this is my 1 degree south, if I say that is my 1 degrees south, and I also have 37 degrees to the east. I also have 37 degrees to the east. If I call this 37 degrees to the east, 37 degrees, remember it's to the east, 37 degrees to the east. So that means this point to Nairobi is here. If we say Nairobi is here, that's where we have Nairobi. And we also have Mandera 4 degrees north. This is the equator, 4 degrees to the north. If we locate our 4 degrees to the north as here, we call this 4 degrees north. 4 degrees north. And 42 degrees to the east. If this is sun, 42 will be behind here. It will be here. Assume that's 42. So this is another Nairobi. So this tells you that Mandera is to the east of. Mandera will be here. So Mandera, because, Mandera will be to the east because it is here and the other one is here. So Mandera is to the east of Nairobi. Mandera is to the east of Nairobi. This is our Nairobi, this is our Mandera. Mandera is to the east of Nairobi. So if Mandera is to the east of Nairobi, so that means Mandera is ahead of Nairobi in terms of time. Mandera is ahead of Nairobi in terms of time. And we know if Mandera is 3 p.m., then Nairobi is behind Mandera. So we shall subtract the time difference from 3 p.m. to get the local time in Nairobi. Now what we do, we need to know the time difference. First of all, for you to know the time difference, the first step you take is to calculate the longitude difference. Remember, we always use, for time, we use longitude difference all the time, because we talked about it's either to the east or to the west, and the east or west we usually talk about the longitude. So we use longitude difference to know the difference in times. Always longitude difference, never use latitude difference. Always use longitude difference. So the longitude difference here is 37, and here we have 42. So the longitude difference, remember this east and east. So we subtract the 42 minus 37 because it's east-east. If you subtract, you get 5 degrees. That is our longitude difference. And therefore, Mandera is 5 degrees east of Nairobi. 5 degrees east of Nairobi. And therefore, the local time differs by 4, because you need to always know an NB. You write somewhere that 1 degree equals to 4 minutes. That one I wrote here. 1 degree equals to 4 minutes. So what about 5? It's 5 times 4, 20 minutes. So the time difference, it is 4 times 5. That is the longitude difference times 4 gives you always the time difference. So time difference is 20 minutes. So that means Nairobi is 20 minutes behind Mandera because it's to the west of Mandera. It is 20 minutes because I said always to the west you subtract and to the east you add. So Nairobi is to the west of Mandera. It is 20 minutes behind. So it will be 3 p.m. minus 20 minutes, which gives you 2:40 p.m. So Nairobi is 2:40 p.m. while Mandera is 3 p.m. So that is how we calculate time in places. That's time in places. Now, example number 2. Example number 2. If the local time of London 52 degrees north, 0 degrees, and so 0 degrees, it means it is at the Greenwich Meridian. If the local time London this is 12 noon, find the local time of Nairobi 1 degree south and 7 degrees east. So it's very important to always sketch, like I said. Very important to always sketch. So always is good to sketch. Always is good to sketch. Always is good to sketch. It's always good to sketch. It is always good to sketch. So if I have my Greenwich Meridian and my equator here, then I have 52 degrees north, 52 degrees north, 52 degrees north. So if I use 52 degrees, maybe let me have it here. I call this my 52. I call this my 52 degrees to the north. And you also have 0 degrees. So the 0 degrees is here at the center. This is the 0 degrees. The Greenwich Meridian is at the 0 degrees longitude. So the point we are talking about, London is here. This is where we have London. Let's call it L. That's where we have London. And then you also have Nairobi, 1 degree south. Nairobi is 1 degree south. Nairobi is 1 degree south. If I talk 1 degree south, let me call it here. Okay, I've just moved it too much, but it's okay. It's just a sketch. But you need to also calculate mathematically. Can it make sense? 1 degrees south. If this is 1 degree south, I call this point, and at 37 degrees east. At 37 degrees east. So 1 degree south and 37 degrees east. So you move, and I have your 37 degrees east here. This is your 37 degrees towards the east. So this is your point. This is your Nairobi, because it is at 1 degree south and 37 degrees east. This is where your Nairobi is. This is where your Nairobi is. If this is where your Nairobi is, remember Nairobi is to the east of London. So in terms of time, Nairobi will be ahead of London. Nairobi will be some minutes or some hours ahead of London. Now what you do, because it's to the east of London, it is always ahead. So what you do, you have to calculate the longitude difference. That's the first step. So the longitude difference, remember this 0 and this 37. So it is 37, whether you add or you subtract, is 37 degrees. That's the longitude difference. So longitude difference times 4 to get the time time difference in terms of minutes. So it will be 4 times that 7, which is 147 minutes. 147 minutes divided by 60. If you divide by 60, 147, I pick my calculator, 148 minutes, 148 minutes, 148 minutes, you will divide by 60, you will find 2.4666666667. Now what you do, that means it's 2 hours. Now the decimal path to get the minutes, the decimal path, so I can first of all subtract 2, I get the decimal path at 0.4666. I multiply by 60 to get the minutes. So it will give exactly 28 minutes. So what you do, you divide. What you get, you take the whole number to be the hours. The decimal part that remains, you multiply by 60 to get the minutes. So it is 2 hours and 28 minutes. 2 hours and 28 minutes. So that is the time difference. And the time difference, remember we are here in London, we want to go to Nairobi, and Nairobi is ahead of London by 2 hours 28 minutes. So what we do, we add 12 plus 2 hours 28, it becomes 14:28 hours, or somebody can say 2:28 p.m. 2:28 p.m. or 14:28 hours. In 24-hour clock system, you just write 14. If you are writing, you write 14:28 hours. That one is correct, 14:28 hours, or you write it as 2:28 p.m. That is still is correct. Now another example 3. If the local time of a point A is 0 degrees north, in simple terms, 0 degrees does not have north or east, it's just 0 degrees. So if we talk at that point is here at the latitude 0 degrees and 170 degrees east. So if we have a 170 degrees east, like somewhere, okay, 170 degrees east, let me just draw 170 degrees east. Is that 7? 170 degrees to the east. If I call this 170, 170, the east is this time on Monday. Find the local time of a point which is at latitude 0 degrees and 170 west. So we have also another 170 to the west. (170 to the west). So if I have another 170 to the west, if you also have a 170 to the west, now we are talking about a point at 0 degrees. 0 degrees is here, so we are talking about a point here. Yes, because that's why we have 170, a point here, and another point here. Both are at 0 degrees latitude, and another point here. Remember, this point is to the west. This point is to the west of the one that is 170 degrees west and 0 degrees is point B. B is to the west of A. This is point A. Point A, and our point is west, and this is to the east. So if we are told that if the local time of A is 12:30 p.m., this is 12:30. So that means on Monday. So that means the time difference you get, you will subtract from here for you to reach west, the time that was at west. What time it was, you subtract the time difference. So the time difference is our longitude difference. And the longitude difference, we have 170 east, 170 west. We add, because it's east and west, opposite, the opposite sides of the Greenwich Meridian. We add. So it's 170 plus 170, which gives you 340 degrees. So times 4 to get the time in minutes. It will be 1306 minutes. We divide by, if you divide that by 60, 1360 divide by 60, it will be 22 hours. The 22 hours, 6.666666. What you do now, like I said, I take my whole number 22 to be the hours, so 22 hours. If I subtract the 22, I will get 0.666. I multiply by 60 to know how many minutes are those. It's exactly 40 minutes. So it is 22 hours and 40 minutes. 22 hours and 40 minutes. So now here you need to think, because it was on Monday. Now you go behind by 22 hours and 40 minutes. What you do, first of all, these are 22 hours and 40 minutes. If I come here 12:30, if I take some 12 hours and 30 minutes, I will remain with 10 hours and 10 minutes. If I take 12 hours, this was PM on Monday. If I go back 12 hours and 12 hours, if I go back 12 hours and 30 minutes, so if I subtract, I will have 0000. That means it was at midnight to Sunday, midnight to Sunday backwards. So midnight to Sunday backwards, it was midnight to Sunday 00 if you subtract 12:30. So I have remained with 10 hours and 10 minutes. From midnight, if you take your midnight to be 24:00, because we usually, if 23 is it is 11 that in that case PM. So if you go back at 12 midnight, if you call it 24:00, I minus 11, if I minus 10, that is because I remained with 10 hours and 10 minutes, so I subtract 10. If I subtract 10, you'll get your time as 10. Remember, you cannot subtract direct. You need to borrow 1 hour from 24, because that's 00 to make it 60. 60 minus 10, you remain with 50. So 50 remain with 23. If you minus 10, you remain with 1350. And 1350, that was on Sunday. That is the previous day, Sunday, 1350, which is the same as 1:50 a.m. which is the same as 1:50 a.m. So the town B was 1:50 a.m. that on Sunday. If this is on Monday, the other one was 1:50 a.m. Sunday. So that is how you do it. Just remember, towards the east you add, and towards the west you subtract. Simple as that. Now let's talk about speed. When we're talking about ships and aircraft, the speed of that is measured in knots, and the speeds are measured mostly in nautical miles and not in kilometers, and they have SI units of knots. That is the speed used by airmen and sailors. Now, in Form 2 we learned about speed as the distance over time taken. So if you know speed is equal to distance over time taken, then now you are able to do questions. As long as you know how to calculate the distance, you are able to know to calculate the sums of distances. Now, for instance, example number 1, a ship leaves Mombasa 4 degrees south at 9 degrees east and sails due east for 98 hours to a point K in Mombasa, that is 4 degrees south and 80 degrees east in the Indian Ocean. Calculate this average speed in nautical miles. Now what to do, it's good to sketch. It's good to sketch. But in this case, remember this 4 degrees and this 4 degrees. So obvious, we are talking about a distance in the latitude. A distance in latitude. But if you sketch, you can easily see we are talking about the distance in the latitude, because if you sketch, oh, no, that's wrong. If I sketch, I should have make a good sketch, at least a better one. If you have there, that is the Greenwich Meridian. This is the equator. I use the equator there. Then I'm told 4 degrees south. Four degrees to the south. If I talk about 4 degrees to the south, this is 4 degrees to the south. 4 degrees to the south, and I also have 39 degrees to the east. 39 degrees to the east. 39 degrees to the east. The point that is 39. At 9 degrees to the east. And I'm also talking about so this is 39 degrees to the east and 4 degrees. So we're talking about a point here. We are talking about a point that is here. That's where the point is. That's where the point is. Then you talk about another 4 degrees south and 80 degrees to the east. 80 degrees to the east will be 80 degrees to the east will be towards this side. Towards this side. That is why we have 80 degrees. So another point here. Remember this one K, this point K to the east of Mombasa. So if this point K to the east of Mombasa, remember this point K is to the east of this point, so the time here is ahead of the time here. So you calculate the average speed in kilometers per hour and in knots. So what you do here, you realize they are on the same latitude of 4 degrees. So we need to find the longitude difference of this 39 degrees, and the other one is 80 degrees east. East we subtract 80 minus 39, which gives you 41 degrees. 41 degrees. Now we calculate the distance in kilometers per hour. In kilometers per hour, we know how to calculate it. It's this 41 all of that times 2 times all this cos of, because they are latitude. So times cos of 4 degrees, you get 49 kilometers. And the speed now, speed is equal to distance over time taken. The distance is that, and the time taken is 98 hours. So we divide by 98 hours, you get 46.41 kilometers per hour. Now the distance in nautical miles, we know we calculate as 60 times the theta times the cos of, that's times alpha times cos of theta, and our alpha is 41, that's the longitude difference times the cos of 4 degrees. If you calculate that, you get your answers 2,454 nautical miles. And therefore the speed is 2454 divided by 98, which gives you 25.04 knots. When you're talking about nautical miles and the hours, the measurement, the unit, SI unit is knots. So the speed is, in this case, is 25.04 knots. 25.04 knots. Now, Example number 2. A ship left point P 10 degrees south, 40 degrees east, and sailed due east for 90 hours at an average speed of 24 knots to a point R. So remember, you are given the speed. So to a point R. If you are given the speed, it's the same process like we were doing. We know we can easily, we know the speed is equal to this. So you just calculate using distance. Now is speed times time. So calculate the distance between P and R. P and R. Remember, it was moving at a speed of 24 knots and at 90 hours. So it is 24 knots times 90 hours, which gives you 2160 nautical miles. Remember, when talking about knots and hours, the distance becomes nautical miles. Now, in kilometers, the distance in kilometers, because you are given here, just convert. Because you are told 1 nautical mile is 1.83 kilometers. 1 nautical mile is 1.853 kilometers. So 1 nautical mile is this. What about 2160 nautical miles? It is 2160 times this one, which gives you 4,002.48 kilometers. So that's the distance in nautical miles. And then you determine the position of R. What you do, like we did from above, we read the longitude. Remember here, R, they are at the same latitude. They will be at the same latitude, which is 10 degrees south. But set to east for 90, that is, and set due to the east. Remember, both are now to the east, but the other one is further to the east. So the angle is more, the longitude is bigger than this. But because they are on the same side, 40 degrees east, and the other one maybe at X degrees east. Now, if that means the longitude difference, you are supposed to subtract. If you are supposed to subtract, so let's call the longitude difference to be theta. If we take our longitude difference to be theta, so that means we take our longitude difference to be theta, and therefore 2160 nautical miles that we have got equals to 60 times theta times the cos of 10, because the latitude is 10. So we divide by 60 times cos 10 to get theta. So we shall have our theta as 2160 divided by 59 point all that point all this, it gives you 36.56 degrees. So that is the difference. But remember, they are towards the east. So remember, the other one, this is in the inside. If you go further, you add this 36 to get the other one. So the other one is 76.56 degrees to east, because both are at the east. So position of R is 10 degrees south, because they are on the same latitude, and 76.56 degrees east. 76.56 degrees east. So that is how you calculate. Part C, find the local time to the nearest minute at point R. At point R, you are asked to find the local time to the nearest minute at point R when the time at P is 11 a.m. The point at P is 11 a.m. And remember, P is, if you remember whatever we have done, P is to the west of R. So R is to the east. R is to the east of west. So that means the time P is this. So the time at R will be the time difference ahead. R will be ahead of P. R will be ahead of P by the time difference. Now, for us to get the time difference, we first of all calculate the longitude difference. And the longitude difference, remember the longitude we have got is 76.56, and the other one longitude is 40 degrees. So we subtract, because they are both at the east, to get the longitude difference, which was 6.56. So this 36.56, our longitude difference, times 4 to get the time in minutes, the time difference in minutes. Time difference in minutes will be 146.24 minutes. Now I said this 1.46.24, just divide direct by 60. You will get that 2.4373, and of course there are so many of them, so you take 4 decimal places, 2.4373. So this means it's 2 hours, and you change this other one to this decimal part into minutes, so it is 2 hours and 0.4373 times 60 minutes, which is 2 hours and 26 minutes. 2 hours 26 minutes. It will be ahead, P will be, R will be ahead of P by 2 hours and 26 minutes. So you had 2 hours 26 minutes from here. If you add 2 here, it become 26 hours. So you can write as 26 hours or 1:26 p.m. 1:26 p.m. So that is the time at R. That's the time at R. That was a comprehensive question covering all the things that we have covered in this topic, and that is supposed to be 10 marks. So such are the questions you expect in an exam, mostly in section B. That is the end of my tutorial today, and thank you for listening. I urge you that you subscribe for me to get more videos and more knowledge from me. Thank you for listening.